Hello everyone, welcome to another episode from Edexcel. So today we are going to talk about concept of mole. Now we discussed about the ions, molecules, as well as we talk about what is RAM and related formula mass. So today we are going to the next part, that is how to do a basic calculation using the concept of mole. Now the word mole is used to represent a huge number which is equal to 6.02 10 to the power 23. Anything which is equal to this number can be called as a 1 mole. For example, if there are this much of stars, 6.02 10 to the power 23 stars, we can say it has 1 mole of stars. 1 mole of stars. If there are this much of trees, we can say 1 mole of trees. So the idea of 1 mole is huge, and we use that one in chemistry to represent the number of atoms or ions and molecules. The importance of this number in chemistry is the scientist Avogadro found that any element with this much number of atoms has a mass equal to its mass number or the RAM value in grams. 6.02 10 to the power 23 of sodium atoms. Sodium is 1123 is equal to 23. What is that 23? 23 grams. 23 grams per mole, 1 mole. So that is the importance of this number with atoms. Not only for atoms, for the molecules as well. 6.02 10 to the power 23 of H2. Let's say hydrogen is 1 into 2, oxygen is 16. So H2 has total molar mass 18. So it is equal to 18 grams per mole. So any molecule or any atom, we can use this concept. So for an atom, the number of atoms equal to Avogadro's constant or the 1 mole has a mass equal to its molar mass, the RAM value in grams, and it is same for the molecule. That much of molecules, 6.02 10 to the power 23, that much of molecules of water or any molecule has a mass equal to its relative formula mass in grams. So we use this concept to derive 2 equations, actually 2 formula to get the calculations. So we are going to derive 2 formulae to find the calculations of substances using this concept. So what is the mole? Anything which is equal to 6.02 10 to the power 23. We call it as 1 mole, or other way around we call it as Avogadro's constant. Right. So we'll see how we can use this concept to derive 2 formulae. Okay, so mass of 1 mole is equal to the molar mass, we say. Capital M, sometimes you use MR, or capital M is also enough. Therefore, if the mass of n number of moles is simple M, 1 mole is equal to capital M. If the mass of n number of moles is simple, then we can say simple M is equal to mass of 1 mole into number of moles. So then we use that one, we derive the first one, n equals simple M over capital M or capital MR we can put. So that's the first formula we derived. The number of moles is equal to the mass divided by its molar mass. Because 1 mole is equal to the molar mass. If the mass of n number of moles is simple M, that is how we derived. So once we derive this one, n equals simple M or capital M, we can derive the second formula I'll write it over here. If the number of substances means ions, molecules, atoms, anything, in 1 mole is equal to capital L, this is equal to 6.02 10 to the power 23. Total number of substances in simple n moles is capital N, and the capital N is equal to 1 mole has this much L into N. So we use this formula with this one to do many calculations in unit 1. So we'll see how we can use this one and this one to do chemical calculations in unit 1. These are the two basic formulas that you have to remember, because in chemistry you won't get any formula. So we'll see how we can use this one and this one for simple calculations. So we'll do one past paper question. It's a very common one. Total number of atoms in 5.4 grams of H2O. It's a very common question. Now what we learned earlier about the atoms and ions is required here. So total number of atoms in 5.4 grams of H2O. To find the atoms, our formula is N equals simple M over capital M, or N equals L into N. They asked in the total number of atoms, so we had to use this formula. But you have to know the number of moles. So I'm going to first find the number of moles. So N equals 5.4 divided by H2O is what? Which is 18. 0.3 moles. Now this is 0.3 moles of H2O. Now in one H2O, what we have learned earlier, you have total 3 atoms. You have 2 hydrogen and 1 oxygen. So if you have 1 mole, you should have 3 moles of atoms. If you have 1 molecule, you should have 3 atoms. Now you have 0.3 moles, which means total atoms would be 0.3 into 3, 0.9 moles of atoms should be there. So 0.9 then. Therefore now we know the number of moles, we know the L, we can find the N. Therefore N equals 6.02 into 10 to the power 23 into 0.9, roughly 5.4 into 10 to the power 23 atoms. Right? That's a very easy question, very common question. So we'll do another question. Number of positive ions. Number of positive ions in 8.25 grams of K2SO4. Again, positive ions. So before you find the number of ions, you have to find the number of moles. So K2SO4, so we will find N equals simple M over capital M. 8.25 divided by potassium is 39.1, that is 2, plus sulfur is 32.1 to 1, so it is 16 into 4. This one gives you 8.25 divided by 39.1 plus 32.1. So you can also do with me 16 into 4. Take the answer 0.047. 0.047 moles. Now, how about they're asking only the positive ions. Now, if they are the total atoms as a previous question, you have 2 potassium, 1 sulfur, 4 oxygen. So you have to multiply this answer by 7. But now they are asking positive ions, or they are cations. We have only 2 cations, that's potassium. Therefore, cations would be 0.047 into 2. You have to multiply the same answer, multiply by 2. 0.094. 0.0946 moles. They are asking total number of ions. Then N equals L into N. So you can find 6.02 10 to the power 23 into this answer 0.0946. So that gives you the final answer. That one into 6.02 10 to the power 23. 5.69. So you can say 5.7 10 to the power 22. 5.7 10 to the power 20. So that's how we do these questions. It's very common questions that you find in Unit 1. There are many questions that comes under this part. So this is how you do the positive ions. So the questions can come in a different way, but this is how we do it. So we'll do one last question and we'll try some past paper questions, how those stuff have asked. It's a very common question. So we'll do one more. So 1.57 10 to the minus 3 is equal to mass or molar mass of aluminium 27 into 2 plus 16 into 3. Then cross multiply and get the answer for M. So M would be this answer into plus 0.16 gram. 0.16 grams. So that's how we do these questions. Not that hard. So we'll see how to do some past paper questions. So we'll do one past paper question. So this one, there are 6.02 10 to the 12 atoms in 0.25 moles of. So here you have 1/4 of a mole. So to make this much number of moles, that atoms, that means you should have 1 mole should be there. So you have to have total 4 atoms. Then only, because 0.25 is 1/4, so you should have total 4 atoms. So this one has only 1, this one has total 3. See, BH3 has total 4 atoms. So answer is BH3 because it has 1 B and 3 hydrogens. So 4 BH3, in BH3 there are 4 total atoms. So 4 into 0.1 to 0.25 gives you total 1 mole. Okay, this is another one. How many molecules are there in 44 grams of carbon monoxide? Carbon monoxide is CO. Carbon and oxygen. So first you will divide the amount, you have to find mass or molar mass. 44 into 28. So that's the number of moles. They are asking molecules, not the atoms. So this is the same thing into 6.02 10 to the power 23. So amount would be equal to, you can get it from the calc, 44 divided by 28 into 6.02 10 to the power 23. 9.46, answer is C. Right? That's it. So we'll do another one. That's one we did. We'll do another one from here. One last question. Yeah, this one. How many ions are in 284 sodium sulfate? So how to find this one? First we have to find the moles. N equals mass over molar mass. 284 divided by 142. Which is 2. So you have 2 moles of sodium sulfate. They are asking only ions. In sodium sulfate you have total 3 ions, 2 sodium plus and 1 sulfate. So this should multiply by 3, that should multiply by 6.02 10 to the power 23. So answer should be 6 10 to the power 24. So that's how we do past paper questions. It's very easy. And we'll see how we can continue this lesson series. Thanks for watching.